So if e to the x stays the same, what happens with other exponential functions like 2 to the x, 3 to the x, 10 to the x, any other base other than e? And you can choose to memorize this, that the derivative of b to the x is b to the x natural log of b. I'll show you how you can use e to the x to prove this one. Okay? So first of all, if you have y equals b to the x, one thing you could do is take the natural log of both sides. If I take the natural log of both sides, I'd have natural log of y equals natural log of b to the x. And this will be a good review of some of your log laws. If I do that, what can I do with that x as an exponent? I could write it in front. So then I would have the natural log of y equals x natural log of b. Now, if I write both of these as, if I take the power of e of both sides, e and natural log are inverses of each other. So anytime you do that, what's going to happen? They're going to cancel out. So that rewrites the equation that I started with as this. So I had started with y equals b to the x, and now I've rearranged it to say that b to the x is the same as e to the x natural log of b. If I do that, I can take the derivative because I know the derivative of e to the x. What is the derivative of e to the x? It's the same. So we start by writing the same. But we have a chain rule because we have a function inside of e to the x. The function inside of the e to the x is just natural log of b, which is a number, times by x. So what will the derivative of that be? Just the number, which is natural log of b. So here's the derivative. And this part was equal to y, right? Which, if we take our green arrow back to the beginning, was just b to the x. And that's a little proof using the fact that we know the derivative of e to the x is e to the x, and using the chain rule, we can derive that the derivative of anything else is b to the x natural log of b. I don't know, maybe just memorizing what it is easier than coming up with the technique of proving it, I'm not sure. But there's the derivative. Now b can be any number, and you could figure it out from there. So now we can apply this to a question. So any exponential will stay the same times by the natural log. Can you see that that will work for natural log of e as well? I'll show you that in a second. But think about using this same law with e to the x, and we'll see why it works as well. Plus the derivative of 5x squared, bring the 2 out in front, subtract 1 on the exponent, and we get 10x. So just up here, if I were to use e to the x natural log of e, remember from the logs course that the natural log of e is just equal to 1. And if you haven't taken logs yet, because you're taking it this semester, that's what you're going to find out. So now you're privy to it a little bit early. But right now it sounds like I'm talking about something that doesn't make any sense, right? Sorry about that.